Good morning, students. Welcome to your physics class. Today we'll continue with chapter number 1, physical quantities and measurement. In the last video we have done the fast revision. Now today we're going to start with measurement of volume 3D concept. So let's start. So first is 3D. What is 3D? 3D space stands for three-dimensional space. So what is a three-dimensional space? It is a geometrical setting for finding the position of any point or object with the help of three values. So if we have three values, we will be able to find the position of any object in the 3D space. Okay. So like for measuring area, we need two dimensions, length and breadth, right? These are called the two dimensions, length and breadth, so that we can find the area of an object. For measuring volume, we need three dimensions, length, breadth and height. So to plot these dimensions on the graph, we need three axes, that are x-axis, y-axis and z-axis. So these three together are known as the 3D space, three-dimensional space. For example, the example is given on your book. Let's go through that. Suppose there is a bird flying in the air and we want to tell the position of this bird. Let there be a pole fixed on the road. You can see here along the y-axis, it is the pole which is on the road. The pole and its shadow are at 90 degrees to each other. So the pole and the shadow of the pole, that is along the z-axis, they both are at 90 degrees to each other. Let the bird be 2 meters away from point O. The point O is the point where the shadow and the pole meets. So let the point is, the bird is 2 meters away. So we will take 2 meters away and 3 meters away along the pole. Along the pole 3 meters away and 1 meter away along the shadow. Okay. Now see the figure. In this figure, road is named as the x-axis, the pole as y-axis and the shadow of the pole as z-axis. So the position of the bird in the 3D can be given as 2, that is 2 meters along the x-axis, that is along the road, 3 meters along the y-axis, that is away from the pole, and then 1 meter along the shadow, right, that is the z-axis. It means that the location of the bird from point O is 2 units along the x-axis, 3 units along the y-axis and 1 unit along the z-axis. In this way, we can give position of any point in the space. This is an example to find one point in a 3D space. How we can write a one point in a 3D space. So 3D space, what is a 3D space and how we can define a point, or we can write a point in a 3D space. So to calculate the volume of an object, we need three values like length, breadth and height. By knowing the length, breadth and height, we can decide the volume of an object. So what is a volume? Volume is defined as the 3D space occupied by an object. So how much space an object is occupying in a three-dimensional space, that is called the volume of that object. Let us understand it with the help of a brick. So we have a brick here. Three-dimensional space occupied by the brick can be given by the three values, that is length along the x-axis, breadth along the z-axis and height along the y-axis. So you can see here, by knowing the length, breadth and height, we can find the volume of this brick, right? You can see here we have the three axes, x-axis, y-axis and z-axis, and we have the length, breadth and height along the three axes. So these three axes will help us in getting the values of the length, breadth and height and help us in finding the volume. The formula to calculate the volume will be length into breadth into height, right? A brick occupies more space than a matchbox. So the volume of the brick is more than that of a matchbox. That is very simple because brick is bigger in size, so it occupies more space, and matchbox is smaller in size, so it occupies lesser space. So the brick will have more volume as compared to the matchbox. Now you can see here, if we put water into if we have a water in a tube and we put stone into it, then what happens? When we put the stone, what happens? The level of the water rises in the tube. So why does it happen? It happens because when we put the stone also has some volume. When you put into the stone into the tube, what happens? The stone will lie down into the tube and it displaces the water away. So what happens? Whatever the volume or whatever the water the stone has displaced, that is risen up in the test tube. So the amount of the water displaced by the stone into the test tube is equal to the volume of the stone, because it will displace the same amount of water as its volume, right? So if we have to find the volume of a stone, we can use this method. We can take a beaker, we can fill it with water, note down the initial reading of the or the level of the water into the beaker, then put the stone into it. As you put the stone into the beaker, you will see there is a rise in the level of the water. So then what you can do is note down the next level of the water minus both the levels of the water, and you will get the volume of the stone also, right? This is how we can calculate volumes. You will learn about it further in this chapter also. Now let's move further. So this activity or this part shows that the dipped stone made some space in the water by displacing water equal to the volume of the stone.